Introduction to Shellcode. So in this lecture, we're going to discuss what Shellcode is and why that's important to us in our gaining access phase. So what is Shellcode? Well, Shellcode is a small piece of code that's used as a payload in the exploitation of a software vulnerability. So this is that exploit piece we talked about during our gaining access lecture. It's easily reused in other exploits as well, so we can use this over and over and over again. There's lots of different kinds of shellcode, and there's several common ones, such as bind and reverse shells. So what does a shellcode do? Well, it typically is going to start a command shell for us, which is why we call it shellcode. We want that command shell, so in Windows that would be the command prompt, in Linux that would be something like the terminal. And this is going to allow the attacker to use interactive command execution on this remote target machine. How do we make shellcode? Well, shellcode is commonly written in machine code, so it's usually written in an assembly language. But any piece of code that performs a similar task can be categorized as shellcode. So it could be written in something like C as well. But most commonly it's going to be written in something like assembly or machine code. Now, why is this important? Well, writing a machine code is pretty darn difficult. Now, most of us are not going to be writing our own shellcode. Now, if you're going to be a really good hacker and a really good attacker, you're going to need to learn how to do that. And there's books out there with lots of different examples of shellcode and how to learn how to do all the shellcoding. We're not going to cover that in this class. That's way beyond the scope. So for us, though, we just want to be able to talk about shellcode and understand what it is and how it works. And we're going to show you some examples of that. So there's two examples of shellcode, bind shell and reverse shell. We're going to talk about these two. In our lab, we're going to use a reverse shell, and the reason why is because we want that interactive command prompt. We want it to go ahead, we're going to run the attack, and then get ourselves back a C prompt when we're attacking Windows, or a terminal prompt in Linux for us to attack with. So let's talk about how bind works first. So with bind, the attacker sends an exploit to a vulnerable service. So let's say you're running something vulnerable like VSFTP. And if you're running that, the attacker sends the exploit to the vulnerable service, the shellcode is going to bind itself to that port 21 for FTP, and then the attacker will be able to make a connection, a separate connection, to port 21. That's how bind works. It binds itself to a port. Now the problem with this is that you have to have those ports open in the firewall for this to work. So if we are the attacker, we're now requiring that the firewall is running FTP and that those ports are open. Now, if we're running an FTP service that's vulnerable, there's a high likelihood that that will be open. But if we're trying to attack something like a web server and you're running something like a Windows desktop, the chances are you're not running port 80 or port 443 on your Windows desktop. You're going to use that for outbound ports, not for inbound ports. So that's why bind shells don't work all the time, but they do work well in a lot of cases. Now, let's talk about how a reverse shell works on the other hand. So a reverse shell is still going to send that exploit to the service. But when it gets to that target, the shellcode itself spawns a connection and calls back to the attacker. You're going to see that in our lab. We're going to set up a listening port on our Kali Linux machine so that when we attack the Windows machine, it will call back to our Linux machine and say, hey, I'm ready to talk to you. And the great thing about this is you don't have to pre-open those ports in the firewall. Firewalls are designed so that things from the inside of the network can reach out and call out, because for instance when you go to a web server you call out on port 80 but you also open a port to come back in on a higher numbered random port. And we're going to do the same thing here to try to hide in traffic. Now once we do this, the attacker machine, our Kali box, is going to listen for that callback, and once it receives that callback we get that two-way communication, and that's when we can start doing this executable reverse shell that gives us full interactive communication. Now, there's another type of payload out there that we talk about that's called a staged payload. Now, what this is usually it's going to be the shellcode itself is too large to pass fully through a single stage. It would be caught too easily. So instead what we do is we break up that shellcode into many smaller stages, sometimes 1 or 2 or 3 or even 4. And what happens, this happens to make the attack quieter. So what happens is I can launch the exploit. The original stage 1 payload goes and gets loaded on the victim machine. It then reaches out and gets stage 2's payload. Stage 2 then gets stage 3, and it keeps building until it gets the entire payload we want to make the full connection for us to be able to do our attack. And that's what a stage payload is. You may hear that come up. So how do stage payloads work? Just like we said, stage 1 is going to happen. The attacker is going to pass a small piece of code to the target. Then stage 2 is going to reach out, grab the larger portion of that payload, and then it will have the full executable two-way communication once the stage 2 has been loaded. So in our lab, what are we going to do? We're going to use a reverse shell. So we're going to send out that exploit on the service. It's going to spawn the connection back to the attacker on a given port. In our case, we're going to use 4444, which is the default for Kali Linux. If we wanted to hide, we could try to make it a random high port, or we could do like 443 so it looks like a secure web tunnel. And then the attacker can listen for a connection back on that port. We're going to use Windows/shell/reverse TCP. This is a staged payload. It's a two-stage payload. So you're going to see that we're going to send it. It's going to say stage 1 received, stage 2 has done, and then once we get stage 2, we'll have that two-way communication for us to be able to talk. So all of this is going to be occurring again. Once again, we're talking in this gaining access stage. Once we are in and we have the interactive two-way communication, that's when we can then move on to other stages, such as escalating our privileges, maintaining our access, and covering our tracks.